It's a pleasure for me to be here among you. And I thank you very much to the organizer for the invitation and to give me the opportunity to present you the results of the Euraloc project, which is an European project. Which investigate the epidemiological question on radiation induced lung opacity among interventional cardiologists. This project was coordinated by Lara Strolens from the Belgian Nuclear Research Center. So the objective of the Euraloc project is to investigate those response relationship between the radiation dose and the lens opacities among the particular community of the interventional cardiologists. And the challenges is number of three, is to achieve a high level of recruitment about this physicist profession in different countries following the same protocol in order to increase the statistical power of the study. The idea also is to provide a distribution of the possible lens dose for each cardiologist rather than a simple mean dose estimation. And finally, to try to deal with the complex design, statistical design in the ophthalmological studies, which is a balance between the high-level object and the individual level object. So just to summarize the previous studies which focalize on the cataract or lens opacities among the interventional cardiologists, there was a recent meta-analysis in 2017 who select 7 studies and who perform a meta-analysis providing a risk ratio, an order of magnitude 3, a significant risk ratio of cataract or lens opacities. But the problem of these different selected studies is, of course, the number of participants and statistical power of the investigation, and also the lack of an individualized dosimetry in order to perform a dose-response modeling. So in the Euraloc project, we try to ask these different questions by different strategies. I will explain the strategies of recruitment, the strategy adopted for the dosimetry, and also the statistical design adopted for the dose response modeling. So concerning the design study of the recruitment, in fact, the cohort is composed on 2 parts, the pre-existing cohort coming from France and Finland, and a new recruitment, a new cohorts in Belgium, Greece, Luxembourg, Germany, Poland, Portugal, Norway, Serbia, and Italy. And the end of recruitment of these new cohorts was in June 2016. And so the whole cohort is composed from different cardiologists and interventional cardiologists from 11 countries in Europe. So the volunteer participants were interviewed by the way of the 2 questionnaires, a medical questionnaire and occupational history questionnaire. So the medical questionnaire aims to collect different individual information about the smoking, health style, and comorbidity, and also familiar history of different age dysfunctions. And concerning the interventional cardiologist, the occupational historical questionnaire is essentially focused on the practice during the whole career over the decades, concerning the number of the procedure, the kind of procedure, and also the different protection tool used during the career practice. And concerning the eye examination data, we listened to some presentation about this system of scoring. We opted in the design on the slit lamp examination performed by a national ophthalmologist. It's important. It's an ophthalmologist who performed the different eye examination. And the scoring was used, the scale of the scoring was the LOX3, LOX with O, LOX3 system examination, which is a reference in order to reduce at maximum, maximum as possible, the variability in the different scoring in the different countries. So in the same way of my colleague, I am not a dosimetrist, but I try to describe the retrospective dosimetry methodology. So just to be very simple, there is 2 main approaches. First approach is based mainly on to estimating the doses concerning the different kind of procedures. And after these different doses of procedures are combined according to the individual historic of career. And of course, there is positive point and negative points. The positive point is it's a method which gives a direct access to the high doses and fully based on the individual occupational history. But of course, the negative points or the limitation are that for a given procedure, that it could be a certain number of possible doses according to the information of so there is one disparity of the possible doses which can associate to a given kind of procedure at a given decade. And also, of course, it correlated to the level of confidence of the self-reporting, and especially for the early years of practice. Concerning the approach 2, the idea is to start from an individual measurement of the whole body using a dosimeter, and after try to make conversion of these whole body doses into high doses. So the principal limitation of this approach is to correctly select the conversion coefficient to obtain the high doses. And also, there is also some uncertainty about the correct use of dosimeter, especially in relation to the position above or not of the apron. Finally, for the dosimetric reconstruction of the whole cohort, it was the approach 1 which was adopted, and basically the study was able to estimate 230 dose measurement according to different kind of procedures, according to different protective tool used and different decades also, and it was able also to precise these doses both on the left and the right eyes. It's very important because we will see after that the radiation, the eye radiation could be highly asymmetric according to the different history working and different procedures performed. And all these measurements were deeply validated and published in a recent paper last year. And once all these dose measurements of procedures are achieved, of course, to obtain the cumulative eye doses, the idea is to combine each of the appropriate dose procedures with the personal history of each cardiologist. And finally, we obtain a distribution, exactly in the same way that the precedent speech, a distribution of possible doses on the left and the right eye for each interventional cardiologist. Okay, so concerning the statistical analysis, the idea is to try to find a statistical design to fully exploit the richness of the database, of the Euraloc database, especially in terms of lateralization of the eye dysfunction and opacities, bilateral, unilateral, left, right, and also the asymmetry of the radiation exposure. And the problem with the several statistical strategies that we can find in literature in the radiation epidemiology context is finally a pooling of the different eye information into the individual level by, for example, choosing as outcome of the eye the more impaired eye, or, for example, as an indication of exposure, the maximum dose to the two eyes. So if we proceed like that, if we summarize the eye information at the individual level, of course, we can lose an important amount of information, especially in kind of lateralization of each exposure or eye stature. So the idea here is to present you the strategy where the eye was a unit of statistical analysis, and the idea is to perform jointly two logistic regression. We told about that previously in the previous speech, but a particular logistic regression where the stature of the given eye is predicted with the different covariates, the radiation dose, but also on the stature of the fellow eyes, which means that this justifies the term of joint regression, logistic regression. And the idea also is in this kind of model, we can adjust the risk estimation or the prevalence comparison. We are in the cross-sectional study here. And we can adjust with the typical covariate or co-founder factors. So it's not important, the mathematical information, but the most important is that the different estimated coefficients give us, have an interpretation in terms of log ratio, log odd ratio. So it's easy to interpret in terms of epidemiological question. And however, this statistical model, which is widely used in ophthalmologist context, is not adapted for the radiation epidemiology context, because the log ratio, the log scale, the log linear scale, is not the reference scale in radiation dose response. The most appropriate in our field is linear quadratic, or linear exponential. So this model was modified in order to give the odd ratios in appropriate scale. And just a final technical slide to explain what is the benefit of this kind of modeling. In fact, this model will be fitted, the coefficient will be estimated using a multinomial regression model. And at the end, this model is able to predict the statute, the different outcome, the unilateral left, unilateral right, and also bilateral prevalence. He is able to separate the different kind of outcome. Okay, so just you have here a flow chart of the processes of the recruitment of the new cohort. In beginning of the new cohort, we begin from 1,500 person contacted. And after response and eligibility, and of course acceptance, we selected 268 interventional cardiologists from the 9 European countries, and in addition of the inclusion of the 106 French interventional cardiologists and the 18 Finnish cardiologists. So on the total of 392 cardiologists, there was some exclusion criteria which were applied, for example, concerning the time activity, not too short, or also concerning the history of chirurgical cataract, etc. And at the end, we obtain a cohort of 318 interventional cardiologists, which is up now the most largest cohort of interventional cardiologists to study especially the effect of radiation exposure. And a control group with the same processes of selection, we obtain a control group of more than 235 persons. So to make a comparison with the previous studies, I give you here the different odd ratios of the posterior subcapsular opacities and cortical opacities. According to the previous results, we found a significant odd ratio for the posterior subcapsular opacities. Order of magnitude of this odd ratio is around 2.5, which is in the same order of magnitude of the previous, perhaps a little less. And the distribution of the different lateralization of the opacities is also interesting, because 3/4 of the opacities were bilateral, but however, 25% of these opacities were unilateral. And it's a good indication of the correlation of the two statue of the two eyes, but also we have to take into account the case of unilateral opacities. So concerning the cortical opacities, we didn't find significant odd ratio. And just for information, we adopt a threshold of 1 or more to define the lens opacities in this study according to the scale, to the adopted scale. So this slide is interesting to give you an idea of the asymmetry of the radiation dose to the eye. You can see here you can see here, so one is this figure is distribution of the ratio left on right, dose, high doses. And you can see that 3/4 of the cardiologists exhibit a more exposed left eye comparing to the right eyes. In fact, the median of this distribution is around 20%. But there is another situation when it can be the double. So concerning the dose-response relationship, we find a significant excess odor ratio according to the linear model. The order of magnitude is around 0.8, and it was significantly associated to the high radiation dose, and at the same order, at the same time at the age. So the age appears here as important risk factor of post-capsular lens opacities. And comparing to the other alternative model in radiation epidemiology, no other model outperform the linear no threshold model. And interesting finding also is the different odor ratios according to the dose category, to the cumulative dose category, to the eyes. And we can see here that even for cardiologists who exhibit cumulative dose to the lens between 50 milligray and 100 milligray, the risk, the prevalence of the postcapsular opacity appears significant here, 0.02. With a shape of the dose response very interesting because it exhibits much more a concave form rather than convex curve. This finding was also, this kind of shape was also be reported in other studies, in other population worker rather than interventional cardiologists. Okay, so just here to give you an idea of the effect of adding different covariates on the model initially fitted with the age and dose. Clearly here, there is no significant results. However, the smallest p-value founded are compatible with the literature and with some well-known risk factors of opacities and cataract. So concerning the dose response threshold, so there is two education about the question of the threshold. You have here in this table the dose analysis relationship according to, after reducing the range of doses. We have, in fact, reduced until 100 milligray, the cumulative dose to the eye of the cardiologist, and we stay on excess odor ratio per gray, borderline significant, even for range doses below 100 milligray. And so it gives us some indication about dose threshold with, if it exists, is relatively low. And another observation also concerning this concavity seems not compatible with the hypothesis of threshold doses, since this kind of dose-response relationship with threshold exhibits much more convex shape. Another important finding in the Euraloc project is to describe the different evolution of work praxis over the time. And what we can here see over the dynamic praxis in homeodynamic, electrophysiology, etc., is that the different procedure performed without any protection clearly decrease over the decades. You have here the decades until the 2080. Intense, and you have also an increase in the use of glass or the ceiling plus glass. However, these projection habits still concern less than 50-100% of the cardiologist. The translation in terms of dose and the annual limitation of this practice was possible thanks to the dosimetrical construction. And what we can see here is that around 13% of the cardiologist exceed the annual limitation of dose of 20 milligray, both in coronary intervention and electrophysiologist. And one interesting finding also is you have here the median dose distribution of the electrophysiologist compared with the median dose distribution over the decades of the coronary intervention. And we can see that we have here, in the last decade, the level of the value of the median dose in the among the electrophysiologists was multiplied by 2, and getting now approximately the same level than the coronary intervention, around 50 milligray per year. And this is mainly due to the new electrophysiology procedures, including cardiac synchronization and pulmonary isolation. And all these results were published in the paper of Joanna Dominiek, which is member of the consortium of Euraloc. Always about the annual limitation of 20 milligray, we have here the result of some analysis concerning the odds ratio of always the posterior subcapsular opacities among cardiologists with mean annual dose below 20 millisievert. And we obtain an odds ratio significant. And you can see here a behavior of the odds ratio of the posterior subcapsular opacities as function of years during the career of the cardiologist with an exposure greater than 20 millisievert. And when we can see that here, even if we have a cardiologist with the whole carrier exposed below 20 milligray, we stay with a significant odds ratio around 1.5. So, of course, we are speaking here about the risk of opacities, mostly of stage 1, which are not yet, perhaps, object to vision impairment or blinding. Finally, according to all these results, it seems important to have some educational tool to try to optimize, calculate, and manage the radiation dose to the eye in the daily practice for the cardiologist, or also for the radiation protection community. And in the Euraloc project, there was 2 educational tools which are available now. And I give you just an example of the interface of this kind of tool. The idea is to enter a kind of procedure, type of procedure here, and we can obtain the dose, the lens dose to the eye. You can have single doses or dose distribution. We can have the percentage of this dose according to the dose limitation per year. And also you can adapt this dose to the eyes with a different protection tool if you have the information. For example, by performing an epidemiological study, you can tune, it's parameter of tuning to see the variation of the dose to the eye. And this tool was also object to publication. So in summary, in this Euraloc study, we established a significant increase in prevalence of posterior subcapsular opacities. The order of magnitude is around 0.88. We demonstrate that the linear dose-response relationship seems the most appropriate to describe these opacities in our cohort. We highlight, of course, the role of the age. And we also investigate the dose-response analysis at relatively low level of doses with some significant prevalence compared to the controls. And also, the Euraloc project provide the lens dose calculation tools to calculate, optimize, and analyze the lens doses in interventional cardiology. Thank you very much for your attention. A special thanks to Lara, who greatly managed the project during the 2 years and even after, and also all the members of the consortium of the 11 partners of the project. Thank you very much.
Thank you very much. Amine, do we have any question?
Well, one question and one comment, really. The first question is in relation to the shape of the dose response that you showed, which looked very odd to me. I mean, the extremely convex, downward curving dose response, which I don't think has been seen in any other group. Is that correct? I mean, I mean, certainly you don't see anything like that in the ABOM data or the Chernobyl liquidator.
Not in Chernobyl liquidator, but in your paper I saw it. This kind of curvature convex.
Yes,
concavity.
But that was due to once you adjusted for age, the evidence for convexity went away. Yeah, so you're saying it's the same thing with you, that it might, it might be an effect of age.
Yeah. But the most interesting is that any other, for example, it was expected that the linear exponential model could perhaps kept this concavity, but it's not the case also in my data. So clearly, in terms of model comparison, it seems the most appropriate linear model because it perhaps more compatible to the high risks with the high doses.
Yeah.